In this video, I'm going to go over how to do factoring by grouping when in a quadratic trinomial a is not equal to 1. This has also been called the AC method. So we're going to work with an example, and while I'm doing the problem, I'll be writing the steps over on the left side, each step that we take. So we're going to start with the expression 8x squared minus 6x minus 5. So my first step is going to be to multiply A and C. Now, if you don't remember, I will actually mark it up here. This is your A value, this is your C value, and technically that's your B value. So we're going to multiply A and C together. So 8 times negative 5 is going to give you negative 40. Then what we're going to do is we are going to list the factors of A times C. So if I have 40, I'm going to list all my factor pairs of 40. I've got 1 times 40, 2 times 20, 3 does not go into that, but 4 does, 4 times 10, and 5 times 8. Now, what we're going to do is we are going to find / choose the set of factors whose sum is B. So now, this is where that negative is going to have to come in, because you'll notice I only wrote these in our positives. We need our sum to be negative 6. If I look at 1 and 40, it doesn't matter if I make 1 negative or 40 negative, I will never get a sum of negative 6. Same with 2 and 20. Whether I make the 2 negative or the 20 negative, there's no way for me to make this negative 6. However, with 4 and 10, there is a way that I can do that. If I make the 10 negative and the 4 positive, I can get negative 6. So that's exactly what I would do. I would use negative 10 and positive 4. So what we're going to do is we're actually going to rewrite the expression by splitting up the B value into the two factors. Okay, so in order for us to see all of this, what I'm going to do is I'm going to actually start by rewriting my original expression. So 8x squared minus 6x minus 5, and we know that negative 6x can be split up into 4 and negative 10. So the way that I'm going to write that, I've got 8x squared minus 10x plus 4x minus 5. So what you should see is that negative 6x, all I did was break it up into the two factors. So I'm kind of undoing what we would normally do to simplify, because negative 10x plus 4x actually simplifies to negative 6, but I've now split it back up. And the reason we do that is because now what we're going to do is we're going to do something called grouping. We are going to group the expression into two pairs. All right, so I'm actually going to use a different color because hopefully that will make this a little easier to see. So I'm going to take this and I'm going to create two groups. So now I've got 8x squared minus 10x grouped together, and I have 4x minus 5 grouped together. Once I do that, that's where the factoring comes in. So if you watch my previous video on finding the GCF, that's a little bit what we're doing. So I'm going to factor out the GCF from each pair. So if I look at 8x squared and 10x, they both have the number 2 in common, and they also both have an x in common. If you need to see where I got that from, I suggest watching my previous video on GCF, but I know that they both could have a 2 divided out, and they both could have an x divided out. So what I'm going to do is I'm going to pull out, like divide out, 2x from this expression. Now, if I were to divide 2x out of 8x squared, what I would have left over is 4x. If I were to divide out 2x from negative 10x, I would have negative 5 left. Okay, so all I did was divide out my GCF. 2x was what they both had in common, and 4x minus 5 is what you have left over after you divide it out. I'm going to do the same thing with this expression. Now, I actually don't see anything that both of these have in common, but technically, if we were to write out all my factor pairs, every single set of expressions has a number in common. 1. If I were to write out all the factors of 4x and all the factors of negative 5, everything always has a 1 in it. So if I factor out 1 from that, it's going to stay exactly the same. I know that one's a little weird. We'll do one where we don't have a 1 that's factored out so we can see it a little easier. But what you should notice is that my two expressions are identical. They are exactly the same, and that's really, really important that they are the same. So I'm actually going to write that over here on the side. What is left in the parentheses should be the same. All right, so here's where it gets a little wonky, and I have most people get stuck here. So I'm actually going to use my highlighter to help me out. Both of these are exactly the same. And if we remember from our GCF video, using the distributive property, if they're both the same and they're both being multiplied by the same thing, I should be able to rewrite this as only 2 expressions. So what I'm going to do is I'm going to only write 4x minus 5 once, but then I'm going to turn that other expression into an expression together. Okay, so these two turned into an expression, and 4x minus 5 stayed exactly the same. Okay, this is called factoring by grouping, and that's exactly what we did. We grouped them together and we found our GCF. So my last step, what I just did, was rewrite as 2 binomials. All right, now what I'm going to do is I'm going to do one more example where I'm not actually writing the steps next to it, but so that we can see what another problem would look like. So we're going to start with the expression 2x squared plus 3x minus 9. Now, again, my first step was to take a and c and multiply them together. That's going to get me negative 18. And I'm going to list all the factors of negative 18. So I've got 1 and 18, 2 and 9, and 3 and 6. Now, I want to find the set of factor pairs that's going to get me a sum of positive 3. There is no way, no matter which number I make negative, for 1 and 18 to get me a sum of 3. Again, with 2 and 9, there is no way, no, it doesn't matter if I make 2 negative or 9 negative, there is no way to make this so that my sum is positive 3. But with 3 and 6, if I make the 3 negative and the 6 positive, I would end up with a sum of positive 3. So I'm going to come over here, and I'm actually going to do this 2 different times. So I have 2x squared plus 3x minus 9, and I'm going to split up this 3x into my 2 factors. So I've got 2x squared minus 3x plus 6x minus 9. Okay, so I split up that b value. My next step, step 5, is to do my group. So I'm going to group these. So now I've got my 2 groups, and I'm going to factor out my GCF. Now, looking at 2x squared and 3x, they don't have a number in common, but they do have a letter. They both have an x that you can factor out. So my greatest common factor for that expression is going to be x. If I factor out or divide out x from 2x squared, I'm going to have 2x left. If I factor out x from negative 3x, I'm going to have negative 3 left. Now, if I'm looking over here, 6x minus 9, they don't have an x in common, but they do have a number. 3 can go into both 6x and negative 9. So I'm going to factor out a 3. If I factor out 3 from 6x, I'm going to have 2x left over. And if I factor out 3 from negative 9, in other words, divide it by 3, I will end up with negative 3. And again, what you should notice is that inside my expression, inside my parentheses, I have this same expression. And on the outside, I now have my new expression. So my final step is to rewrite this. I'm going to have x plus 3 and 2x minus 3. And that would be my final answer. Now, the question that I get most often with this is, do I have to do it in that order? And no. So that's why I said I'm going to do this twice. I'm actually going to do this over here using the other order. So if I were to start with 2x squared plus 3x minus 9, and I were to split up the 3x in the other order, 2x squared plus 6x minus 3x minus 9, I'm still going to get the same answer. It's going to look a little different, but I'm going to get the same answer. So I've split it up. I'm going to do my grouping. Actually, I should have put that over here. And then I'll have my little plus sign in the middle, because adding a negative is the same as subtracting. So ignore that little parenthesis right there. If I had an eraser, I would use it. So 2x squared plus 6x. In that expression, my GCF would be 2x. And if I divide 2x from 2x squared, I would only have an x left. If I divide 2x from 6x, I would have 3 left over. Over here, I have negative 3x minus 9. Now, the greatest common factor in this is going to be negative 3. Okay, I always want to take out that negative if I can. Since they both are negative, I will take out that negative 3. Now, if I divide negative 3x by negative 3, all I'm going to have left is an x. And if I divide negative 9 by negative 3, I will have positive 3 left. And so you'll see what we have left over again is exactly the same. I have x plus 3 now in both of my expressions, or sorry, both of my parentheses, and on the outside I now have 2x minus 3. So it looks different on that second to last step, but the answer is still the same. I still end up with x plus 3 and 2x minus 3 as my 2 binomials.